So we'll see what happens. All right, you're having trouble just setting it up, Jeff. That's not technology. Okay. So any other questions from homework or? So the main thing I want you to, oh, what's up? Five two?
Yeah, 5-2-26.
Oh yeah. So we did one like this where you had to pay, I can't remember, $3 I think it was to get a lottery ticket. And then we said so forth. So this one's just like that. It says you have to pay 50 cents to be able to pick 4 digits. And if you select the same sequence of 4 digits that are drawn, you win and collect $2,788. It's a very strange amount of money, but hey. So what are the possible outcomes here? Oh. No. What are the possible outcomes? How many outcomes are there? So if you buy a ticket, what could happen to you? You could win, or you could lose, right? So there's 2 outcomes. So what does that mean monetarily? So the outcomes are win, lose, right? And the example we did last time was, I think there were a couple options for win, wasn't there? I thought there was a $100, a $5,000 or something, whatever that was. So there might be more than one outcome, but here there's only you win or you lose, really. That doesn't mean it's 50-50, is it? Is it a 50% chance you win just because there's win or lose? Of course not, because there's a lot more ways to lose, right? So what are the actual money amounts for winning and losing? If I lose, how much money did I actually
lose? $3.
Be careful, not the 3. That was what my example for this problem, New Jersey lottery. They say you got to pay 50 cents to get a ticket. So if you lose, you actually just lose 50 cents. If you win, they give you $2,788. How much money did you make overall? $2,787.50. Then you got to subtract off that 50 cents you had to pay to play, right? So basically, all your outcomes just go down by the cost to play. Because I didn't make a full $27.88 because I had to pay 50 cents just to play it. What's the probability of winning? And this is what, they don't tell you directly. They say there's 4-digit numbers, right? So what's the probability you win? So you can pick anything from 0000 up to 9999. And how many numbers is that? 1,000, right? Because from 0 to 9 is 10. From 0 to 99 is 100. So from 0 to 999, that's 1,000. So it's probably you win. Good. You got 1 chance out of 1,000. What's probably you lose? Careful. If you don't have the one number that wins, that means you have one of the 999 numbers that loses, right? Which is actually the whole idea. I mean, I want there to be a lot of ways to lose if I'm the guy setting this up, so that I actually end up making money, right? That's the whole purpose. Now it's really just an XP of X problem. I know the numbers are a little funkier. You can make these into decimals if you wanted to, but you just multiply across, right? Because the formula for the average, the formula for the expected value is sum of XP of X. So I need to have XP of X's before I can add them up, right? So the mean will be the sum of these guys. I can't add them until I make them. So what is this times 1 over 1,000? It's just going to move the decimal over 3 places, right? When you divide by 1,000, so it'll be 2.78750. Don't need the orbital. Is that all right? Of course, if you do the calculator, you get the same thing. What is negative 0.5 times 999 over 1,000?
Negative 0.4995.
Negative point
4995.
4995.
Negative.
That sounds right. So then what's your expected value then? Add those up, right? So you get
288.
88? 0.288? Oh, you know something I just realized. Great way to start the class off. It's not 3-digit numbers, right? It's 4-digit numbers. So shouldn't this be out of, if I go 0 to 0, 0, 0, 0 to 9999, that is 10,000 numbers.
Because if you were to do that, you only have 500 bucks. But there's only 500.
Right? So it should be, yeah, it's my fault for not really double checking that. Is that cool? Should be out of 10,000. 0 to 9, there's 10. So 0 to 9999, there's one more 10,000. Cool? Because I'm adding in that 0, 0, 0, 0 option. All right. So the reason I kind of looked at it to double check is this is weird. My expected value should not be positive, or else the lottery is losing money. They don't want to lose money. They want to make money, right? My expected value should be negative for playing this game. So now it should come out negative, actually, if I do this. So these are based on that wrong, out of 1,000. Still the same idea. You still multiply across. My probabilities were just off by a 0. Right. If it was a pick 3, it would have been out of 1,000, but it's a pick 4. It should be out of 10,000.
0.27875.
Oh, here. And this is still going to be like 0.49995 or something like that. There's too many nines, I don't know.
Negative 0.0499. We have 1 too many nines.
Oh, 1 too many nines? Negative 0.0? No, that doesn't make any sense. Negative 0.4995, right? Because this is almost 1. It should be really close to 1 times this. And now what does my expected value come out to be? Negative something, right? That makes more sense. I expect my expected value at a casino, in a lottery, to be negative. So if my expected value is negative, I expect to lose money. What do the people on the other side expect to do? The casino people, the lottery people, they expect to make money. So any casino game, basically, you have a negative expected value. Play it enough, you will lose that much money on average. So if I play this lottery enough, I'll lose, what does this come out to be?
8207.
What is it now? 297.
You're missing a 9.
2. I'm missing a 9? All right, anyway. Is there 3 9s in there?
Yeah.
All right. Whatever that comes out to be, that's your expected value. It's going to be negative 22 cents roughly. Okay. Got a ton of people out there with calculators. You should be helping me out.
Negative
Negative 0.2. 2212? All right. So expect to lose about 22 cents on average. So if I play this game 100 times, I expect to lose $22.12. That's my expected losses, right? And that's good for them because they're expecting to make that money from me. So on the other way to look at it, if 1 million people play this game, play this lottery, then that state, New Jersey, expects to make 1 million times this money. Do you guys see what I'm saying? That's how that works. I know, like back in Virginia, they were supposed to use that money for education, and they ended up not. They ended up dipping into it for all kinds of other stuff, but that's beside the point. So it ends up being just like an XP of X problem. You just have to set up your own probabilities. Just make sure you get it out of the right number. Yeah. Any other questions on homework? Okay. So on 5.5, and is it 5.4, I kind of snuck this in a little bit, but I think you guys already told me, if I have a binomial situation, the probability is that formula we've been using, the n choose x. The mean of the situation, and again, cool. The mean of the situation, and this only makes sense, like I said earlier, that whole, if I make 40% of my free throws and I take 10 of them, you expect me to make 4. Now, if I make 3 or 5, that's not unusual. The next step would be what's unusual. But if I can figure out the mean, the n times the p. So that's like 40% of my free throws, and I take 10 of them. So that wise makes sense. I multiply those two. To figure out what's unusual, what do I need on top of this? Standard deviation, right? Because that kind of sets off the distance in statistics. How far away do I have to be from the means for it to start being weird? And in this case, it's this guy. So you've noticed now, we basically have had 3 different forms of these formulas. The mean was add them all up divided by the number, and then it was sum of xp of x, and now it's np. Why does it keep changing? Because it has to go along with the situation. Right? So I understand this is the easiest problem we've had so far. This is the nicest little formula. You can't beat that. That's an awesome formula. Kicks ass. It's normally very easy to tell n and p. But why won't it work for anything else? Because I can't identify p for everything else, right? For a binomial problem, they're going to tell me straight out, 89% of people like to eat ice cream. It's probably less than really true, but anyway. Well, there you go. They tell me p. And then I pick 30 people. There's n. Sweet. But if I have this situation, p will keep changing all the time, won't it? I can't use this formula then. Okay, cool. So that's why we have different formulas based on the situation I'm in. What's the best formula for that situation? That's what we use. Cool. So back here, just reminding you guys, this was sum of x p of x, and then the standard deviation was this free p. Remember that x squared p of x thing? Yes?
So the difference is just you have those, so on the left-hand side, are those discrete probabilities?
Yeah, these are, well, I mean, this is discrete also.
So
You can take a binomial problem. In fact, we did this. If you look on the handout, there's the x p of x. I can make a binomial look like this, and then use these formulas. I wouldn't be that crazy, because those formulas are nice already. But it can't go this way, right? This works for any probability distribution, period. This specifically works if I have a binomial distribution. Cool.
based on the problem.
Exactly, based on the situation I'm in. Okay. So 5.4 is actually, 5.4 will be really nice. They're going to ask you for this, they're going to ask you for this, and then they're going to ask you for the minimum and maximum expected value. And how do you find those again? How do you find the minimum expected value?
2 standard deviations, or minus 2 squared.
Yeah, the mean down 2 steps, and the max value is the mean up 2 steps. Ooh. So, right, they'll give you a situation, they'll say 10% of M&Ms are green. You open up a bag, and you find, and there's 500 M&Ms in there, and you find 7 green ones. Is that, you know, they're going to ask you that situation, and then they're going to, you just figure out the average, which is how much you expect to see, figure out how much you expect it to deviate by, and then see what's usual. The number they ask you about is inside here, that's expected. If it's outside of here, it's not expected, right? So let's actually do a real quick problem like that. Those are well, they're pretty easy actually. But let's do the one I just said. What was it? I said, I don't know if this is true, but 10% of M&Ms are green is the claim. We open up a bag, a bag with, I don't know how many, let's just say 90 M&Ms. Would it be unusual to find